Definition. Energy is a scalar quantity that measures the ability of a body to do work. Law of conservation of energy states that energy is neither created nor destroyed. It is converted from one form to another. So as for mechanical energy, there are different forms. There's the gravitational potential energy, kinetic energy, and elastic potential energy. So we can see, or we are going to see later, examples in which gravitational potential energy is converted into kinetic and the opposite. So we have that the gravitational here is an example of gravitational potential energy. It is the car here has stored gravitational potential energy because it is at a certain height above a specified reference, while the other car, blue in color, is moving on the horizontal axis, so it possesses kinetic energy. So kinetic energy is related to motion, while GPE, gravitational potential energy, is related to height above a reference. And finally, elastic potential energy, it's the energy stored by an elastic body that is either stretched or compressed. Kinetic energy, by definition, is the energy possessed by an object due to motion. The formula is KE, K kinetic and E energy, equal half times mass times speed squared, where m is the mass of the body in kilograms and v is the speed of the body in meter per second. Remarks: to convert from kilometer per hour to meter per second, you have to divide by 3.6, and from meter per second to kilometer per hour, you have to multiply by 3.6. Okay, so the proof of this conversion was done before in previous years in grade 8 and 10. So now you have to take it as it is and apply it. The kinetic energy of an object is 0 when the object is at rest, so V equal 0. If it's at rest, no speed, and speed 0, so kinetic energy is equal to 0. Or if the object is released without initial speed, so V initial equals 0. Or the object reaches a maximum height, so that V equals 0. So like when you have when you throw something and it reaches its maximum height, it stops at the maximum height, then it goes backward down. So when it reaches the maximum point, its speed is 0. Application 4. Calculate the kinetic energy in each of the following cases. A runner of mass 50 kilograms with a speed of 4.5 meter per second. Direct application, kinetic energy equal half mv squared. We have them both given in SI unit. Do the calculation and we get 506.25 joules. Part B, a car of 1,300 kilograms traveling with a speed of 90 kilometers per hour. So here you have 90 kilometers per hour not given in the SI unit, while mass is given in the SI unit. So you have to convert from kilometer per hour to meter per second. So you divide by 3.6. So it's equal to 25 meter per second. Then you substitute in the formula. Kinetic energy equals half mv squared. So half times 1,300 times 25 squared equal 406,250 joules. And for C, a 10-gram bullet moving with a speed of 100 meters per second. The mass is given in grams, not in kilograms. So you have to convert it by dividing by 1,000, 0.01 kilograms. And you do the substitution and multiplication, you obtain 50 joules. But please you make sure that you square this V. Application 5, a 4 kilogram object moving with a speed V. It consumes a kinetic energy 20 joules. Calculate its speed. So now you have the kinetic energy, you want the speed, which is marked with red. Kinetic energy equal half mv squared. 20 equal half 4 times v squared. So 4 times half is 2. 20 equal 2 times v squared. Divide by 2 both sides. You get 2 and 2 cancels here, and we are left with 20 over 2. So v squared is 10. So we need v, not v squared. We have to make square root 10. We take, usually in math, you say when you do square root, you say plus or minus. For this case in physics, you always take the positive value because it is a physical quantity. So plus radical 10, which is equal to 3.162 meters per second. Now the gravitational potential energy, by definition, is the energy that is stored in an object due to the position or height relative to a reference level of GPE equal 0 joules. So the reference level taken usually is its height is 0, it's considered to be 0, and thus the GPE is equal to 0 of an object on the reference. So it could be not it could be expressed as P dot E index G, or a GPE. So these are the two notations for gravitational potential energy. It's equal to the mass times the gravity times the height, mass of the body in kilograms, gravity or gravitational acceleration in meter per second squared, and the height is in meter. So there are three cases: positive gravitational potential energy equal to 0 or negative gravitational potential energy. Why is that? Because simply it's affected by the height. If the height is above the reference, then it's positive. On the reference, 0, and below the reference, it is negative. However, the mass and the gravity are always positive quantities. So positive times positive times positive is positive. Positive times negative is negative. Positive times 0 is 0. Now more details about this. Sorry. Potential energy is positive that when the center of mass of the object is above the reference. Okay, and it is plus potential energy equal to 0 when the center of mass of the object is on the reference, and the potential energy is negative when the center of mass of the object is below the reference. So it's negative, positive, 0 here. And here I would like to stress on something that we study objects that could be considered like point objects. That's why the point object is just like the center of mass of this object.